I'm waiting. All right, so chapter 5 is not a big deal. Chapter 5 is continuing with pretty much your, hold on a second, your parent graphs as well as your calculator graphing. Okay. Your vertical, horizontal shifts, they still are in play. 5.1 is rational, more rational, and we might do some algebra in here in 5.3. But most of 5.1 and 5.2 is going to be your family of graphs. What I mean? Well, remember a while back we had family of graphs. We had all of these, and we had linear, we had parabola, we had cubic, we had even, where the evens, the parabola starts to square out on the bottom, and the odds, the higher the odds, the more this squares out. And then we had absolute value, and then we had the square root function, and I think these are the next two, or the next function, these two right here are what we're going to be studying in 5.1 and 5.2. Okay, so that's your family growth that we did back in the first unit. You might want to pull that out of your notebook and add these two. If I hadn't already added them, I might have added them in that unit. I don't know. But we're going to be talking about in 5.1 and 5.2, we're going to be talking about two graphs, basically. We're going to be talking about f of x is equal to 1 over x, and f of x is equal to 1 over x squared. Now, these are the two parent graphs. The 1 over x, it looks like this. I call it a half volcano. And then, of course, the other half is down here. Whereas the x squared is the volcano. It looks like a volcano. Now, in 5.1 and 5.2, you're going to be studying about these, and it's going to be horizontal shift, vertical shift, orientation, and your vertical asymptotes and your horizontal asymptotes. All of this you already know. Okay. If this is a negative, then it's going to be flipped. This is on this side, that will be a negative if it looks like this. Negative over here is going to look like this. So the orientation, you know the orientation. Of course, if it's a 2, if that's 2 over x, then you know it's going to be narrow. So that means it's going to be compressed this way and stretched this way and this way. If it is 1/2, 1 over 2x, then you know it's going to be stretched that way and compressed this way. So all of those things that we learned with the parabola and the other functions, they apply here also. A vertical shift, horizontal shift. So let's go to the next page. Now I'm kind of hitting this with a broad brush because I think y'all understand horizontal and vertical shifts and all that, okay? I'm just going to kind of hit that first, and then I'm going to go into vertical and horizontal asymptotes because that's the new material in here is the vertical and horizontal asymptotes. So if I give you a big A graph, and you know that the parent function is f of x is equal to 1 over x. And you know it looks like that. And I say, well, I want to change it a little bit, and I want to do f of x is equal to 1 over x plus 2. Well, at that point, you know you've got a horizontal shift of 2 to the left. 1, 2. So now we got an imaginary vertical axis here, which is called the vertical asymptote, which we'll get to eventually. And now it's going to look like this. So we just shifted that black one 2 places to the left. And all of you should say, oh yeah, I understand that because just like the parabola and all the other things that we learned. So you should say that, and okay, no problem. All right, let's do another one. Let's do in Verde, let's do f of x is equal to 1 over x plus 2 minus 3. Well, you know that that's a vertical shift, so basically the blue is going to shift down 1, 2, 3. So now we've got a new horizontal asymptote, and the vertical is the same. So now we've got
you have a work email.
That graph. So now the green is a horizontal shift 2 to the left, 1, 2, and then 3 down, 1, 1, 2, 3. And you're going to do this with the compression also. If I give you f of x is equal to 3 over x plus 2 minus 3. Well, that's going to be the same thing as the green, except it's going to be compressed this way and stretched this way. So it's going to look more like this. Same graph, except now it's being pushed more toward the center of the origin. And of course, if this was 1 over 4, then that would be another, and I'll do that in orange. F of x is equal to 1 over 4 times x plus 2 minus 3. Well, now the same graph that was green is now going to be stretched along the x-axis and compressed along the y-axis. So now it's going to look like this. It's going to be wider. So you see that the same things that we learned with absolute value, which you're going to learn in 6, with the parabola, the vertical and horizontal shifts, the compression and orientation, all of that applies to this. And it applies to this guy also. So I'll go over that right quick. And again, you can do this on your calculator and it'll show you the same thing. So our parent graph here is f of x is equal to 1 over x squared. There's your parent graph. So if I do f of x, we'll do it in blue. Then I have a horizontal shift of 2 to the right. So now my new, which is called a vertical asymptote, is a mirror of the y-axis, is over here now. And my new function is the same function as the black function, except it's moved over 2 to the right. Now, I'm not going to go through all the different ones. I'm going to do a vertical, and then I'm going to do a flip. So let's do a vertical shift. And a vertical shift would be the same function, f of x is equal to 1 over x minus 2 quantity squared. Then that would be 1, 2, 3. And now we've got a new horizontal asymptote. And there's the vertical asymptote. So now there's our function in pink. And if we did the negative is real simple. F of x is equal to negative 1 over x minus 2 quantity squared minus 3. Then that would be flipped right here. So again, as you can see, the vertical and horizontal shift and orientation, of course, if you compress this way, it's going to make it closer to the origin. If you compress this way, it's going to bring this closer to the origin, and it's going to put, so it's going to, so calculator, and you can check yourself. Remember, I told you 5.1 and 5.2 is a lot of calculator. So I'm going to do, first of all, I'm going to do dashed. So y is equal, and I'm going to change the parent graph. I'm going to make it dashed. And I'm going to call it 1 divided by parentheses x squared close parentheses. I hate these calculators. Hold on. Delete parentheses. And then I'm going to make the second one. I'll make it 1 over parentheses x minus 2 squared. X minus 2 quantity squared. And then I'll make the third one. I'll make it this this green one right here, and I'll make it dark. So that's going to be 1 or negative 1 divided by parentheses. And it's not going to delete that stuff no matter what. So I got to hit delete, delete. thing. Let me start it over. Let me go back. And negative 1 divided by parentheses x minus 2, x minus 2 quantity squared, and then I'm going to subtract 3. All right, so if you put all this in your calculator, you're going to see the original. There's the original, and then it moved over two to the right, and now, so you see it'll graph it for you. So you need to be utilizing your calculator in 5.1 and 5.2, as well as what you've learned with the vertical and horizontal shifts. Now, let me go to the book and let's get into the stuff you may not have seen before. And that is the test for vertical and horizontal asymptotes. And as soon as it comes up, we'll go over it. There's a reason I block all these tests together. I block all of them together because I believe it's a little bit less stressful on students when you can block them by concepts instead of mixing them all up. And I don't know why I had to do that, but okay. I went into my last class book and I didn't have a problem. This one's I'm having to do this, so I don't know what's up. Okay, well, I don't think this is going to be very productive. You go to Google, vertical and horizontal asymptote test. I was hoping they'd give us, yeah, we can use this, but I don't want to use that, but okay, that's good enough. That's the way I do it. Save image. And we'll just call it download. And I'll pull it up. Let me see if that thing has come through yet. There we go. And I have no idea what page it's on, so we're just going to go 5.1. And I'm trying to show you something because I don't want to have to write it all out. So if you just be patient with me here in a second, I'll have it. We've already discussed all this. They're showing you vertical and horizontal shifts. Okay, it must be in 5.2 then. There we go. Now we're cooking with peanut OIL. And I'm looking for a box. There's the box. Okay, write that down. Now you don't have to write it down, of course, but page 304. You can write down the gist of it. To find your vertical horizontal, to find your vertical asymptotes, you set the denominator equal to 0. To find, I'll write this down in summary. To find vertical asymptotes, set denominator equal to 0 and solve. Okay, that's number one. Number two, you need to check for horizontal asymptotes. Well, there's three categories. If the numerator is a lesser degree than the denominator, if the numerator has a lesser degree than the denominator, then you just use y is equal to 0 as the vertical, the horizontal asymptote. If the numerator and the denominator are the same degree, you just use the coefficient. And if the degree of the numerator is higher than the degree of the, if the degree of the numerator is higher than the degree of the denominator, you use long division to find the horizontal asymptote, or in most cases, the oblique asymptote. Okay, so this is probably the stuff that you either suck at or you don't remember very much, or you don't remember at all because you've never seen it. Okay, I don't know. It depends on what you've had as far as, and I just wrote that right there. That's what I mean by in summary. To find the vertical asymptote, you set the denominator equal to 0. To find the horizontal asymptote, if the numerator has a lesser degree than the denominator, then y is equal to 0. Your horizontal asymptote is the y-axis. I'm sorry, x-axis. Sorry, x-axis. If the numerator and the denominator have the same degree, then you just take the coefficient, and I'll show you how to do that. And then if the numerator has a higher degree than the denominator, you use long division. So let's look in the book and let's just find one so I don't have to make one up, because I don't want to make one up. So let's find one. Okay, here's one right here. So I want you to write that down. And that's going to be f of x is equal to x plus 1 over 2x squared plus 5x minus 3. Okay, so here's our function. And we have no idea what it looks like right now, but we're going to get some idea here in just a second. We know it's x squared function, so it's going to look something like the volcano, but we got to figure out what it's going to look like. So set the denominator equal to 0, find your vertical asymptotes. Vertical asymptotes, I'm going to set 2x squared plus 5x minus 3 equal to 0. Now you actually can do completing the square if you want to, or you can try to reverse FOIL. We'll try that first. 1 and 3 goes there. Got to be careful here because these are different signs, and you can't just say 2 times 3 and 1 times 1 because it may not work out that way. 2 times 3 is 6, and 1, okay, that will work. 2x and 1x, and we want a positive, so that means that 6 has to be positive. This is unlike, so 2x minus 1 and x plus 3 is equal to 0. 2x minus 1 is equal to 0. X plus 3 is equal to 0. Be a 1 and divide by 2, x is equal to 1/2, and x is equal to -3. These are your two vertical lines. So to the handy dandy, I'm going to go to my handy dandy, I'll put this back in just a second. I'm going to draw a big graph here. And at 1/2, I've got a vertical asymptote. So I'm going to draw a vertical line, and it's going to be dashed. Now, what does that represent? Can somebody tell me what the vertical asymptote represents? Come on, algebra professionals. Some of y'all that's had algebra for 15 years, and you wrote the book on algebra. Tell me what the vertical asymptote represents. The vertical asymptote represents where the domain is affected. Remember me telling you, when we were doing all those vertical and horizontal shifts, and we were doing completing the square, and I said that the domain is not affected unless it's a rational or a radical. This is a rational. What happens when you plug 1/2 into this function? What's going to happen? Somebody tell me. Somebody's got to have some kind of a guess. What's going to happen when I plug 1/2 or -3 into this function? What's going to happen? Nobody knows? Can y'all hear me? Somebody say yes if you can hear me.
I'm just typing out.
Okay. You just psyched out or what? Does anybody have any guess what happens when you plug in 1/2 and -3 into this function? What did we set the denominator equal to?
Zero.
Thank you. So if I set the denominator equal to 0, then what's going to happen when I plug 1/2 and -3 into the denominator? I'm going to get what? Okay, I'm going to get 0. So if I plug 1/2 and -3 into this function, I'm going to get a 0 in the denominator, and I can't have that. So I can't use 1/2 and -3 in the domain. So the domain is going to equal all numbers except for 1/2 and what? -3. So my domain is affected by these two numbers. So my domain is going to equal all real numbers except x cannot equal 1/2 or -3 and -3. So that's what the vertical asymptotes represent. The vertical asymptote represents where the domain is what? Affected. And as you can see, I cannot use x equals 3, negative 3. I can't use it. So I have to put a dashed line there because the function does not exist at negative 3. The function also does not exist at 1/2. Now, let's go out and see what else we can say about the function. We know that the domain is affected. F of x is equal to x plus 1 over 2x squared plus 5x minus 3. What is the degree of the numerator? It's x to the first. Degree of the denominator is x to the second. So the degree of the numerator is less than the degree of the denominator. So therefore, my horizontal asymptote is y equal to 0, which is the x-axis. So now I'm going to take my handy-dandy yellow marker, and I'm going to mark the x-axis dashed, meaning that my function cannot touch it either.
You have a work email.
So now I know that my function is going to be part of these 3 sections. Okay? And I know that my x squared, I know that's going to be some kind of volcano looking do-jigger. It's going to be, it may be alternating, but there's going to be a function somewhere that looks, you know. Now, there's no way to draw this unless you actually put in points, and that's too cumbersome. So what you do is you do it with the calculator. Y is equal to the first one. I'm not gonna do it in. So I'm gonna hit. I'm gonna get my regular. Dang it. There. And I'm gonna do parentheses. X plus 1. Close parentheses, divided by parentheses, 2x squared, x squared, 2x squared plus 5x minus 3, and graph. Let me get rid of the other ones. Delete. And there's what it looks like. And it's going to look like this. And we've got a function like this. And function like this. There's the volcano. Right there. Now the domain of this function, domain is negative infinity to negative 3. From negative 3 to 1/2, and from 1/2 to infinity. From 1/2 to infinity. That's the domain, and the range is going to be everywhere except for the yellow. So the range is going to be from negative infinity to 0, and from 0 to infinity. And that's an example of what you're going to be doing in 5.2. It's a conglomeration of handwork, which means doing this right here, and testing for the horizontal asymptote, and then using your calculator and your hand graph to graph the final product. And they will usually ask you for the domain and range.
Message coming in on secured channel.
Okay. All right, let's look at another example. And we'll see their answer, what they got. Okay, they got the y-intercept. We didn't get the y-intercept. Plug in 0 for x. But here they said equal to 0. The x-intercept, that's good. It should be on the next page. There we go. Okay, we got it drawn wrong. I'm sorry. I couldn't see that. It's not drawn. It's like this. Sorry. It's like that. I didn't see that on the graph. All right, here's one. That's a good test question right there. So let's do that one next. So f of x is equal to 2x plus 1 divided by x minus 3. Okay, I want you to do, and we can do the y and x intercept. We can do that too. So let's go there. When you want to do the x-intercept, you plug in 0 for what? For y. When you want to do the y-intercept, you plug in 0 for x. So I'm going to plug in 0 for x. What do I get? I just plugged in 0 for x. What do I get?
Negative 1/3.
Thank you. Plug in 0 for y. Multiply both sides by x minus 3. Minus 1, 2x, divided by 2. And negative 1/2 is your x-intercept. Now let's set the denominator equal to 0. X minus 3 is equal to 0. X cannot equal 3. So vertical asymptote at x is equal to 3. And the horizontal asymptote, here's one. The degrees are the same. The degree of the top is the first degree. The second is, so 2 over 1 is 2. So your horizontal asymptote is at y equal to 2. And this one's going out, so it goes in the trash pile. And let me break open my brand new box. And let's draw a graph. We know that we've got a x-intercept at -1/2. And we've got a y-intercept at 0, 1/3. And our vertical asymptote, x is equal to 3. And a horizontal asymptote of x, y is equal to 2. 1, 2. And of course, you would use your calculator to draw it. And now back in the day, back before we had calculators, you had to actually do a chart, and you had to plug in 5 or 6 numbers to get, or 10 numbers to get some idea of where this thing was going. But now you just take your handy dandy calculator and do it, or in this case, go back to the text and they should draw a picture. There it is. I've got the wrong intercepts. -1/2. Oh, -1/3. Sorry. And it looks like that. And up here will be going like this. So some questions you may be asked to find the vertical and the horizontal asymptotes. Some you're just going to be asked to find the domain and range. The domain is -infinity, 2, 3, and then from 3 to +infinity. Range, -infinity to 2, and then from 2 to infinity. Any questions? As you can see, it's not, it's not very difficult if you use the calculator with what you've learned in the past 2 or 3 units. Hopefully you see that. And hopefully some of y'all are more fluent with the graph now. Most of you should be feeling pretty comfortable with sketching graphs with minimum information. Yes, no, maybe. Okay, nobody's gonna say anything. Today's not Monday, y'all. Y'all know today's hump day. Okay, so y'all can talk a little bit. I understand on Monday, but come on, it's hump day. Y'all suck. All right, next, let's go ahead and go to the attendance and let me see who wasn't here Monday. Turn this off and turn the recorder off.